Hello everyone, so today we are going to solve a problem from YDSE. In this question, they have given that a young double slit apparatus is immersed in a liquid of refractive index mu1. The slit plane touches the liquid surface. A parallel beam of monochromatic light of wavelength lambda in air is incident normally on the slits. They are asking first question, find the fringe width. So you can see this diagram. So here in this question, they are saying what is the fringe width. So definitely suppose initially there is no slit. So initially there is no glass slab. Glass slab will be introduced later. So in the first question, what they're asking fringe width. What is the fringe width? So if you know the formula for fringe width, beta equal to lambda capital D by small d. Correct. Now when the light enters in a medium, so in a medium of refractive index mu1. So here mu1, you can say this mu1 is the refractive index of the water. So when light enters in the medium of refractive index mu1, the new beta becomes lambda by mu1 capital D by small d. So this is the answer of the first question. Let us see the second question. So in the second question, they're saying that if one of the slits, say S2, is covered by a transparent slab of refractive index mu2 and thickness T as shown, find the new position of central maxima. So here I have introduced a small glass slab of mu2, refractive index is mu2, correct? And thickness is T. Thickness of this is given T. So what is the new position of maxima? Okay. Now, what is the path difference introduced? So part B, path difference introduced by the glass slab. Path difference by glass slab will be what? Path difference by the glass slab delta x will be what? Mu2 minus 1, correct, into t. Okay, so what will happen? The new interference pattern, definitely it will shift up, so it will not be at center now. Okay, so definitely it will shift up. So when it is shifting up, what is the extra path traveled from S1? Extra path, that is d sine theta, correct? So here what I can write, delta x equal to mu2 minus 1t minus d sine theta. So for central maxima, this has to be 0. So I can write mu2 minus 1 t minus d sine theta can be written as tan theta, should be equal to 0. So mu2 minus 1 t minus d, what is tan theta? From this diagram, tan theta will be y by capital D. So I can write y by capital D equal to 0. So what is the value of y? Value of y I am getting capital D mu2 minus 1 t divided by small d. So this is the new location of central maxima. This is the new location of central maxima. Okay, third question. So next part C. So for part C, now the other slit S1 is also covered by a slab of same thickness and refractive index mu. Refractive index, this is mu3. Okay, as shown in the figure, due to which the central maxima recovers its position. Find the value of mu3. So if I introduce another glass slab in front of S1 such that the central maxima recovers its position, that means the central maxima finally will be at O. So in this case, what is the path difference? Path difference, try to understand one point, that path difference, whatever introduced by mu2, same path difference has to be introduced by mu3. Then net path difference will be 0. So central maxima will be at O only. Correct. So what is the path difference introduced by mu2? Path difference introduced by mu2, can I write? Mu2 minus 1 into t. Path difference introduced by mu3. Mu3 is inside water, correct? So I can write mu3 by mu1 minus 1 into t. So this, if this is 0, this equal, then net path difference will be 0. So I can write mu2 should be equal to mu3 by mu1. So from here, mu1 into mu2 equal to mu3. Okay. Part D. Next part, find the ratio of intensities at O in the three conditions A, B and C. So in all three conditions, the ratio of intensity. So in the first case and third case, first and third intensity will be I naught. That is intensity of central maximum. Correct. So I'll write 4 I naught here. So if intensity of every light coming from every slit is I naught, so at central maxima it will be 4 I naught. So I2 will be, we know I2, I is what? I naught, 4 I naught cos square 5 by 2. Correct? What is path difference? Path difference delta x. Path difference was mu 2 minus 1 t. Mu 2 minus 1 into t. This is the path difference. So, what will be the phase difference? Phi will be 2 pi by lambda 2 pi by lambda into mu 2 minus 1 into t. So 5 by 2 will be pi by lambda mu 2 minus 1 into t. So if I write I2 will be 4 I naught cos square pi by lambda mu 2 minus 1 t. This is the intensity of I2. So I can write I1 to I2 to I3 equal to 1 to cos square pi by lambda mu minus 1 t is to 1. So this is the intensity in three cases. Okay. Hope you understood.